Hi, I'm Anika Datingginoo, and today I will be illustrating to you the different techniques used in channel coding, which are parity check, repetition, and timing distance. Let's start off with parity check. Parity check is an error detection method that adds a parity bit to a binary data string. The parity bit ensures that the number of ones in the string is either even, which is an even parity, or odd, which is an odd parity. If the data is altered, the change in parity indicates an error. To better understand this, let's have this example. If the original data is 1010, let's first count the number of ones. The number of ones in this data is 2, which is an even number. The parity bit added will be 0 to keep it even. Thus, the number will be 10100. This data will be transmitted over a communication channel to the receiver. Suppose the one bit is altered during transmission due to noise. 10100 changes to 10110. The number of ones are now 3, which is an odd number. Since it is an odd number of ones, there has been an error that occurred during transmission. Now let's move on to repetition. Repetition code enhances error detection and correction by sending each bit multiple times. The receiver uses a majority vote to determine the original bit, increasing redundancy and accuracy. Let's have this example. Let's say that the original data is 1011. Each bit is sent 3 times to create redundancy. Redundancy is basically extra copies of data, which is helpful in detecting and fixing errors by providing backups that can be used if the original data is damaged or lost. Thus, the transmitted data is 1110001111111. Suppose that during transmission an error occurs. The data received is 11101011111. Now we will analyze the received data by comparing each group of 3 bits received with the expected repetition. So for our first group, the majority is 1. Our second group, the majority is 0. Our third group, the majority is 1. And for the last, the majority is also 1. Using repetition, we constructed the original data as 1011. Lastly, let's have the Hamming distance. Hamming distance measures the number of differing bit positions between two binary strings. It is used in error detection and correction to determine how many bit changes are needed to convert one string into another. Let's use these 2 bit strings as an example. So we have bit string number 1 and bit string number 2. Comparing each bit, what I find easier to do is putting them side by side so that we can better determine their differing and similar positions. Comparing each bit position, we notice that both strings are similar in only the first, second, and fifth position, or x sub 1, x sub 2, and x sub 5. The bits differ in the third and fourth position. Calculating its Hamming distance, we get 2. Okay, so after learning the 3 techniques on channel coding, let's apply it to these few problems. Number 1. In an even parity scheme, what would be the correct parity bit for the binary string 00000000? To determine the correct parity bit, we count the number of ones in the string. Counting the ones in this example, we find there are 0 ones. Since the number of ones in our binary string is 0, which is already even, According to the even parity rule, we add a parity bit of 0. Therefore, the correct parity bit for the binary string 00000000 in an even parity scheme is 0. Number 2, find the Hamming distance given this. Firstly, let's calculate the Hamming distance of x and y. We will now count the positions where bits differ. So there are 4. Therefore, the Hamming distance of x and y is equal to 4. We're going to repeat the same steps to calculate the Hamming distance for the remaining, which are the Hamming distances of x and z and y. So pause this video and try to solve it yourself. Finally, we've successfully calculated the Hamming distances between x, y, and z. Thank you for watching this tutorial on channel coding techniques. I hope you have a clear understanding of parity check, repetition, and Hamming distance. These methods are essential for ensuring data integrity and reliability in communication systems. Remember, effective error detection and correction can significantly improve the performance of your network.